So I'm going to be talking to you about this environmental, social and governance in respect to packhouses, because that's why you're all here today. So if we look at the fresh produce value chain, you're all familiar with this, and you probably are all in that second step, the packhouse. That's why you're here. That's of interest to you. Now these I mentioned just now, all these abbreviations in the industry, and we've now got this new one, ESG, environmental. So what is ESG? It's not just a trend, it's a strategic framework for creating a resilient and future-proof business. For packhouses, this means a deep commitment to stewardship, social well-being and transparent governance. So what do the letters stand for? E is the environment. S is social, so this is dealing with all your people, which packhouses are hugely dependent upon. And then governance, which we'll talk a bit about, those are all the wretched rules that we have to abide by, whether it be DALRAD or Department of Agriculture, or more particularly the importing countries with all their residue limits and quality requirements. So, managing the E, resources in ESG. How do we do this? Well, we have to be aware of our carbon emissions. We have to do a comprehensive audit of all our sources, from electricity to cold storage, water usage, and for fuel for transportation. And I think one of the things we often don't pay enough attention to is the use of water and how we recycle it. Now, all this supplies us with data which we can use as a baseline for implementing reduction strategies for the use of all those products. So we're all aware of this and how conscious the world is, absolutely correctly so, about it. And how can we try and reduce that? Well, energy use, I'm sure the one thing that a packhouse has in huge amounts is a vast surface area of a roof. So it's ideal for solar panels, but solar panels, as we all know, have their limitations. So there's a huge investment in that if necessary, but also in the batteries to keep the power for when there's no sun or it's raining. The other thing is, in new builds, ensuring the refrigeration plant is optimized. Now, I've had over my career a lot to do with people and when they're developing new cold stores and packhouses. And the one thing that came to my attention was that one of the most expensive pieces of equipment, apart from all the compressors and the motors to run that, are the evaporator coils, because they're quite complex pieces of equipment. And when the engineers would present the plan and then the costings, the accountants who were going to pay for this, or were being used by the owners or the investors to pay for this, they would see, well, where can we cut some money out? How can we cut some money out? You can't make your compressor smaller, you can't make the motor smaller, but where you can is try and reduce the size of the evaporator coils. And that is bad news, because they frost up, they're not as efficient. And so I'm just pointing this out. That's a thing to really be aware of. Watch the accountants, because they'll all try and save money at the beginning, but at the end, it's going to cost you more money. So if any of you are accountants, sorry guys, but that's the truth. Appropriate insulation specs for a refrigeration plant with the correct cooling capacity. There I mention it, evaporator coils with sufficient surface area for the cubic meters of the facility. And then double airlocks, very important. Often there's only a single airlock, particularly to the outside. Double airlocks. They cost more money, but they will save you money because you use less energy cooling the facility down when the forklifts and trucks move in and out. So, adopting renewable energy, investing in solar panels and batteries to power packhouse operations, which can drastically reduce reliance on fossil fuels. And ultimately, Eskom is if you have your own diesel plant or whatever, that's fossil fuels. Now, the next important thing is water. And many of you might recognize this picture. It's of Theovatus Kloof Dam from the bridge that runs over it. So you're looking north here. Managing water use. Water is a very precious resource, and packhouses are significant consumers. And something that I think all of us don't pay enough attention to is that actually South Africa is a water-stressed country. We don't think it. We look outside here and it's all beautifully green because we're blessed in the Western Cape. We have sufficient rain to fill the dams and we have all the vineyards and orchards. But it is a water-stressed country, so we have to be very conscious of the use of our water. So in implementing water benchmarking projects helps us to identify and address inefficiencies. Technologies like closed-loop water recycling systems can drastically reduce water usage by cleaning and reusing wash water. And that's the important thing, this reusing of wash water. And particularly managing of wastewater. When we can't clean the water anymore, what do you do with it? You don't just put a little channel and put it into a little stream. You have to have some retention pond rather than it getting into the open environment, because there's often traces of all sorts of things, diphenylamine and fungicides, etc. in there. Minimizing packaging waste. So there's a global push to reduce plastic waste, and this puts packhouses right at the forefront of this challenge because you have to make use of a lot of plastic in packaging. So we must try and embrace a circular economy model by sourcing packaging from recycled or biodegradable materials. And once again, if we talked about biodegradable, that's often the more expensive option. But these are things that we need to consider because it's important when it eventually ends up. We often think, well, it's not our problem because it's exported, but the world is our problem. So I think we just have to have a big global view on that. The S is a social responsibility. Managing the S. This is the relationships with people, namely our employees, our community, and also those who are part of the supply chain. So, a very typical site there of a pack house with very, very dependent on labor. All the industries are. So we must manage this aspect of the business very carefully. So pack houses can be powerful anchors in their communities. They create local employment, very importantly. They invest in training and they facilitate development programs. And in particular, what I've noticed is that many of the communities, sorry, is it not working properly? Okay, thank you. Many of the communities, farming communities, will have invested in decent accommodation for labor. There's obviously a challenge where seasonal labor is used, but that's just a national problem. Managing the G. This is about relationship with people. Our employees are important, and what are our goals? Right, governance. I put this picture in because this is what it feels like sometimes when you're involved in trying to deal with all the various regulatory bodies. They throw at you these vast amounts of rules and regulations. So how do you manage the G? Well, my thoughts are transparency and accountability. Publishing regular ESG reports, it builds trust with customers, investors, and it demonstrates a commitment to our goals. Risk management. A robust governance framework helps to proactively identify and mitigate risks from climate-related disruptions to regulatory changes. So one's always got to be aware of what are the current regulations and what is anticipated that is going to be changing into the future. So how do we manage our pack house? Well, I like to use this m to the power of 4, which is man must measure to manage. Because if you don't know what the problem is, how are you going to manage it? And the only way to manage it is to measure. So I'm a big advocate for measuring whatever you can, because it gives you data, which is very, very useful. So let's just think a moment about our product that we're sending. And this is a quotation out of this book here from University of California, Davis, which is regarded as one of the top institutions in the world for post-harvest. Controlling product temperature and reducing the amount of time the product is at less than optimal temperatures are the most important methods of slowing quality loss in perishables. So, two things there. The right temperature, but making sure that it stays at the right temperature as long as possible. So that means as limited amount of breaks in your cold supply chain as possible. So, a little bit of biology. We must remember this. Fruit and vegetables are still alive. Sometimes we tend to forget that, but it's a living organism, and it has sugars in it that have been given to it by the mother plant through the energy of the sun, converting carbon dioxide into sugars, and the sugars react with oxygen and they give energy, which gives off heat. That's why our bodies are hot. We are respiring, we're converting sugars in our body to energy, and carbon dioxide and water. So the important thing there is that it's still alive, but it's giving off heat. So the refrigeration and the cold chain are very, very important. Now, just to give you an idea, I don't expect you to digest this table, but the important thing is, if we look at something like apples and the rate, don't worry about the units, but you can see from 0 degrees to 20 degrees, it goes from 700 units to 5,700. So there's an enormous increase. And even from 0 to 5 degrees, it doubles. But if you look at something like asparagus, 9,700 units at 0 degrees. What's wrong? Is it okay? 9,700 units. And as the temperature goes up, so it rockets. So keeping the product cold is very important. And the moment the cold chain is broken, that stuff starts to respire faster, and it's harder to get it cool again. So what we need in a cold supply chain is real-time visibility with a dashboard that you can look at and monitor what's going on. So you need real-time end-to-end visibility. So wireless sensors and data loggers are placed in cold rooms and packhouses during pre-cooling and inside containers that transmit data to a centralized dashboard. This allows managers to see the exact temperature of their produce at any given moment, whether it's in the packhouse or, we're not talking so much export now, but the containers at sea. These dashboards are not just for viewing, they are for action. So you can actually follow up on what they're telling you. They can be programmed with predefined temperature thresholds. If the temperature in a cold room or container deviates from the optimum range, the system will automatically send alerts via email or text so that you know. And that can go to any device, your cell phone, a laptop, a desktop, and 24/7. Proactive anomaly detection. What do I mean by anomaly? It's gone out of the range that you want it to be. This allows managers, owners, whomever to react immediately to prevent spoilage. Because one of the things I didn't put in here to illustrate is that, of course, fungi are a big problem for us, managing the growth of fungi. And they are just like the fruit, apples or pears or peaches. The higher the temperature, the faster they grow, the higher the respiration rate of fungi. So it's very important to help preventing spoilage. So a dashboard can alert staff to faulty refrigeration unit or a container door or a cold room door that has been left open. So this is a 3D image created of some work I did years ago. So this cube is a cold room, And the temperatures, I haven't put the ranges in, but blue is the coldest, and it's cold at the top there because they were close to the evaporators and the cold air coming out. But you can see on the right-hand side, there is a yellow patch where it was much warmer. And that was because there was a door there that vehicular traffic was coming in and out of. So this is the kind of thing that is helpful in managing the opening and closing of doors, for example. This is the frequency of temperatures above 4 degrees in a cold room over 1 day. So each one of these is an hour block, and you can see the number of times it went over 4 degrees. And the interesting thing is, you can see it 2 to 3 in the morning, there was much more, then it dropped off. And then here, 12 right through to about 19, 2000, the temperatures were well above 4. And that shows the times of day when there was activity within that facility, particularly here in the latter part of the day, where they were moving produce in and out of the cold room. Very helpful in trying to manage those temperatures. So a dashboard, it provides a very accurate temperature and humidity data, 24 real-time temperature access on multiple Android and PC devices, chamber maps with sensors, locations that provide real-time temperature and humidity information, and a pop-up display. So this one I've shown. So here we've got a grid. Imagine this is a cold room, and we've just divided it into these squares, and then you put that into a packhouse situation, and the little green thermometers, that's where the temperature sensors were played. And you can see just below 0.1 to 4, there's a radio antenna that's capturing the data from those sensors and sending it via cell phone into the cloud, and then from the cloud to your laptop or cell phone or DC, wherever your office, should I say, wherever you want it. And then it's very important to spread those evenly throughout the facility so you get an idea of where the hot spots are. So if we look at location 7, which is down here, at that time it was 3.96. And what's also useful about these sort of systems, because each of those little units that are transmitting have a battery in them, it actually tells you how the battery's doing. And this is another way of displaying the data. You've got it like a speedometer, if you will, or a rev counter. You just put the different temperatures on that. So room 1 is clearly an ambient room, as is room 2. No, not room 2. Room 1 is ambient, and rooms 2 and 3 are chilled rooms. You can see at the bottom there, that's giving the average temperature over whatever that defined period is. This is the type of thing you can achieve, and you can see it real time. And here is taking that same data, but putting it like that previous one I showed with the bar chart over this 24-hour period. And you can see here at 1600 to 1700, there was a huge spike, and there's the 4 degrees. You can see 4, and that went up to 10. Clearly there was a lot of activity going on, and the different colors are the different positions within that cold store. So there, yeah, it's 10.1 degrees. Here's an example of another one. That's over the past 1 day. And there you can see the peak was there, 4.9. So this is a typical chart that one can achieve. And you can see here what we've done. We've segmented it and shown what happened at those particular times of the day. So product activate, the device is activated, crates loaded, trailer doors closed, and truck preparing for departure. So the truck departs from some cold store facility to a pack house, and then you can see when it arrives at destination, the temperatures immediately drop up. And the blue line's the air temperature, and what you will note very interestingly is how the product temperature always is behind the change in temperature of the air. And this is something, also this was done over I don't know, this was about a 2-week period, but where I've put the red block in, that was the period when the product was coming out of the pack house. You can see this wasn't too bad because the temperature was just on 4 degrees. Later on the cold chain, you can see things went horribly wrong, but we're not going to talk about that today. It was just this period of the pack house I wanted to illustrate. So here, once again, we have this segmentation, and you can do this with colors. So this is an example of some other work that we did, and the colors are illustrated below. So we've got none between 4 and 5. We've got some between 5 and 6, which are the blue, and then we've got a lot at 6 to 7 and also 7 to 8. So you can see it's very hard to manage temperatures within a cube, a big cube. And what's very alarming there is the red ones. And unfortunately, that's where access doors are, and that's always a challenge to manage. That's why I mentioned double airlocks. So data-driven decision-making. Historical data is very valuable. By analyzing trends, you can see weak points in the supply chain and hotspots, and where you get reoccurring spikes, you can address that. And importantly, and I think this last sentence is useful, data informs process improvements, leading to greater efficiency, reducing energy consumption, and a more reliable product for export. And I think often we kind of forget that you're using more energy than necessary if this cold chain is broken and you're having to keep recooling it to the desired temperature. Real-time visibility, end-to-end visibility, very important. I'm kind of repeating this here, so I'm going to skip over this, but management can see the exact temperatures of their produce at any given moment in the pack house. They're not just for viewing, they're for action, and they are programmed with predefined thresholds. This, having an automatic system, is very, very useful. You know, you can imagine, particularly the folk who are involved with stone fruit, everybody wants to take a break at Christmas, and you're sitting at your Strandhuis in Stilbaai or somewhere, but the packhouse is 200 k's away. To get a warning is very helpful, because maybe you can phone the appropriate person who's still at the packhouse to go and do something about it. If the temperature in a cold room deviates from the optimal range, that's just what I've said, you automatically get an alert. Why is this thing? This thing is doubled up. This allows managers to immediately prevent spoilage, can alert staff to faulty refrigeration unit, and very importantly, and often the case, the store room door left over. And many years ago, I did a project for one of the big supermarket chains, and we found that at the back of the stores, where they had the cold rooms that serviced all the refrigerated display cabinets, the staff were always leaving the doors open. So we managed to get them to import from the UK units that were set above the door on the frame and then on the door, and then when the door closed, the system was silent. But inside the packhouse itself, there were loudspeakers, and the moment this was left open for, you could set it 5 minutes or 10 minutes, it would blast out a message. The cold room door is open, please close the cold room door. And we thought it would be quite fun to put a nice sort of vernacular Cape coloured Afrikaans voice in there, saying close whatever adjective you want, door, so that it would make them pay attention to it. But those are very useful things. We've done that one. And we have talked about this: greater efficiency, reduced energy consumption. So, in summing up, I've kind of used my time up. Our motto is you've got to keep it cold all the time. Keep it cold. Keep it clean. Packhouses should be immaculately clean. And something that I know you pay attention to, but sometimes you've got to pay as much attention as you possibly can to. And the other important thing is you've got to keep it moving along the cold chain. So there's my little summation of some of the thoughts and sharing some of the experiences we've had.